Okay, good afternoon. How do we say good afternoon in Spanish? Buenas tardes. Okay, I learned something new. So my name is Ruth, and I am so excited to be here. It's my first time in Spain. And today I'm going to be talking about F#. And also a little background about me is I'm a cloud developer advocate for Microsoft. How many of you guys know what that is? Don't worry, I don't know either. No, it's a brand new role that I just started like last month. And it's like a long title. I'm like, okay, whatever. Whenever I tell somebody, they don't know what that is. But I have an amazing session prepared for you guys. A little bit of background for me is I'm a computer science major. I'm from New York City. And my background is mostly around Java development. So I do, over the past 15 years or so, my background has been developing applications in Java. Then I migrated to doing a lot of data science type of stuff, doing data ETL type of stuff. So I do both object-oriented and also data science. But one thing that piqued my interest is the new surge of functional programming. Because when I was in college, I remember, you have to take all the calculus classes. Then to start into programming, you get to learn functional programming. So how many of you guys have heard of LIPS scheme? Okay, you may not want to put your hand up. It shows how old we are. But yeah, that's when I started coding, and it totally made sense for me, coming from a mathematical way of building functions, because with math, you have a function and you execute it. Then from there, we moved on to learn object-oriented programming. So coming back and learning F# was interesting. It was almost like putting my brain upside down. And especially with object-oriented, we're all aware of all the different design patterns when you're an object-oriented developer. How many of you guys can name at least 5 design patterns? Okay, 10? Okay. So I'm dealing with the right audience. So that's one thing I was very frustrated, even though you're coding, of course, a lot of these experts come up with design patterns to help us learn good guidelines in programming. But the problem is so many. And at the end of the day, when you need to write a code, you need to go straight to the point, write your code, and keep it moving. But one thing I learned about functional programming that I really enjoy, especially dealing with functions, is it's very straight to the point. It's not very complicated. So for me, when I'm dealing with something new, or I'm learning a new language, or I'm in a new arena, there's 4 things that I want to know. First of all, what is it? So if you're new to functional programming, you need to know what is it? What's the whole big hype around it? When do I use it? When do I not use it? Who's using it? Am I the only one using it? Should I even waste my time around this? Then another thing is, what are the benefits of it? So today I want to go through and cover all these areas around functional programming, around F#, and give you an idea of why it's such an exciting technology. Okay, so F# is older than object-oriented, believe it or not. A lot of people think it's a new programming language, but realistically, it started back in 2000, I think the year 2000, and it gained momentum around 2005. Initially, it was created or invented by a team within Microsoft. So a lot of misconception when people hear of F# is, oh, I have to go and learn something yet again in Microsoft. But don't worry, even though, yeah, we're on Microsoft, our main intention right now, especially with our new CEO, is meeting our developers where they are. We're not here to shove any new programming language to you. We want to meet you where you are at. So F# is an open source programming, functional programming language. Another thing that's is very unique about F# is it's an immutable type of programming. So when we say immutable is when you define things, especially when you're dealing with object-oriented programming, and you have different objects that you're sharing, the data can change. But with F#, the good thing is when you're dealing with the languages, I mean, the data doesn't change, which is a good advantage because you have a function. All you need to worry about is what does a function do? You put in some data in it, it does something, and you keep it moving. You don't need to worry about passing in data here, worrying about stuff like inheritance and whatnot. When your data is changing, when is it not changing? So that's another good component of it. Then another thing is the way we call functions. So when you're calling functions, it's, you call a function with the data. You don't need to worry about different, what's it called? You don't need to worry about different programs or functions that you need to pass the data into. You concentrate on one thing, pass the data in, it does one thing, and you continue moving on. And if you look at the data between object-oriented and functional programming is if you're to code in F#, it's very few lines of code compared to object-oriented. So that's another good area that it's gained a lot of momentum. So if you have a product or you have an application out there, it's very quick to market. Then This is the paradigm that C# is, F# is based out of. So you have C#, you have Visual Basic, and you have F#. It's built on the .NET framework and libraries, so you can totally leverage all of those libraries, and you have like a common language runtime environment. Oh yeah, one thing to mention is when you're dealing with F#, you don't have to reinvent a lot of things. You know, like we have like predefined functions and whatnot. So in that library, you can just use those libraries and implement the code that you need to implement and not worry about having to rewrite code. So we can get into details like that. So one thing I want to note is, okay, what's so awesome about F#? You can build better code with less time. It's very easy to learn. Software is becoming more complex. So this is a very important topic. If you guys are aware of things like Hadoop, distributed programming, think of it almost like functional program. Because now we have the cloud. You no longer have like your servers in-house. You can write a function and distribute it along different servers and not worry about any of the state or any of the data changing or clashing. So it's very good when you're dealing with distributed type of environments, especially the benefits that the cloud gives us. It's very lightweight, like I mentioned. My phone matting is bad. You focus on the problem area. You have less bug rates, and in order to test and develop, you have a very short time. So this is an example of writing a code in F#. So if you can see, this is a simple function that you want to take the sum of squares. So you declare what the function is, you pass in the values, you have like a pipeline. So you can pass in the values into multiple functions all within one code. If you were to do it in something like C# or object-oriented coding, first of all, you have to declare a class. Then within the class, you have to sit there and write all of these different functionalities or algorithm to execute the same type of task. So if you can look at just something simple like that, you can achieve all of that in F#. Any questions so far? No? All right. So the next thing I want to discuss is there's a another misconception out there around S# is most people that use it is mostly around mathematical type of scenarios or financial type of scenarios, but that's not the case. Almost anything that you can do in terms of programming, you can achieve with F#. So you can use it virtually anywhere. Microservices is another excellent example. So if you can think of microservices is you have like different teams that have to implement maybe a program or a logic. But the problem with dealing with a lot of teams is you have to worry about when the code is being shared. Also resources, like if you have a code and you have to implement stuff like data fields and whatnot, let's say your team is like 50 developers, you have to go through and have meetings with them and come up with some kind of standard to come up with an agreement that yes, we need to change our code to all be in sync with that. So these are areas where microservices was introduced to alleviate all of that. So you can be on a team, let's say, that deals with just a payment system. Or you can be on a team that deals with maybe billing, that type of thing. But all of these teams can write their code in isolation, put it in production, put it in a distributed, scalable environment, and be able to execute and not worry about the interdependencies. And you're very fast to market. So this is a very huge area where a lot of customers are using that. Next thing is data science. That one, like the misconception, it goes to show, yeah, anything around mathematical computation and data science, you deal with a lot of computational models and whatnot. F# is a very good tool to be able to do all of that. So that's a very huge area. Machine learning is another area. Financing is another area. E-commerce is another area. The cloud is a limit. Search engines, architectural firms are using F#. So as you can see, there's a diverse audience out there that's using F#. Okay. So to piggyback on scenarios where F# is being used, one of our biggest companies that's using F# is a company called Jet.com. So Jet.com, they started I think in San Francisco, New Jersey. They're literally the rival of Amazon. So any e-commerce out there that you have like a website where you want to purchase something, you can do that using Jet.com. And the cool thing about Jet.com that's giving Amazon the right for their money, I'm not sure how many of you guys shop at Amazon.com, but for me, I do that a lot. So let's say you purchase something, right? I purchase maybe a cleanser from one brand, but at the same time, I need a lotion and I need some other stuff. Guess what? For each item that I purchase, that's a different mailing and shipping calculation that Amazon is gonna calculate. So I'm spending a lot more money with Amazon. So what Jet.com does is their algorithm is more of seeing how many things you have in your shopping cart. So they do have warehouses like AWS, but the thing is, with them, you can figure out, they can figure out that, okay, with these items that you have in your shopping cart, are there other similar things within that geo region that you can leverage from? So the more items you have there, the more geo region that it is, you can get discounts off of it in terms of the delivery. Then another company is Amyris. So Amyris is more, they deal with DNA type of stuff. So they were having issues like sitting there and kind of categorizing DNA type of information. So that's like a lot of heavy computation and categorizing of what's it called, DNA. So with something like that, if you're to do it with, let's say, object-oriented programming, that one you can sit there for months and try and write code. But what they were able to do is leverage F#, and were able to come up with an algorithm that was able to speed up the number of processes that they were able to compute with that. Oh yeah, one thing back to the, what's it called, Jet.com. When they first started their company, they actually wrote the same code for C# and the same code for F#. The difference between the performance between the two was like night and day, because they were able to transact a lot of, handle a lot of, what's it called, transactions at a given time. And their code base was like very short. So they decided to trash their C#, even though it's Microsoft proprietary, but it just goes to show how powerful F# is. Then these are a number of other companies out there that are also using F#. Any questions so far? Okay. So the next thing is we're going to get into the Microsoft side of things. So this event is about Lambda, right? So you guys are learning different languages, a lot of open source languages around functional programming. But the thing is, where do you use it? So one thing that Microsoft has, one of the services that they have is called Azure Functions. So no matter what language that you are coding in, you can write your code, put it into Azure Functions, and just forget about it. You don't need to worry about provisioning how many servers in the back end that you need. The good thing about Azure Functions is you're only charged for when your code actually gets executed, and the amount of, I'll say, processes that you ran at that time. If you guys are familiar with Amazon, it's like kind of like Lambda type of services. And Azure Functions were built on web apps, which is our predecessor for Azure Functions. So as you can see, the languages that the Azure Functions support is a lot of open sources. It supports .NET, it supports Node.js, it supports PowerShell, Bash, Python, PHP. Recently, we announced the support for Java. Here, these are basically a few languages, but a lot of open source executables that you can think of that you need to run, you can use what's it called? Azure Functions around that. And with all of that, there are other things like continuous integration. App services is when you're dealing with building applications or mobile applications and whatnot. Okay, so with Azure Functions, there's the whole theory of why you need Azure Functions is this whole concept of stateless computing. So you can have your code is serverless. You don't need to worry about any servers, or you pay per invocation. It's highly productive. You have less control, so you're not sitting there looking at the spikes in your processes to figure out, okay, do I need to scale up or scale down? All of that is done for you. So it's almost like a PaaS type of service. It's cost efficient, even when you have like very spiky loads. You fire it and you forget about it, basically. Any questions? Okay. This is pretty much redundant to what we just discussed. You have an abstraction of the services, so you don't need to deal with the VMs. It's event-driven. So this is a key thing around functional programming, because with functional programming, you have a program, right? But you only execute it when you need it. How can I rephrase this? You have a program that does something, right? But it's only when you pass in some kind of data, it does what it needs to do, and it'll move on. It's not going to do any other thing. So it's the same for Azure Functions. Azure Functions are event-driven. So when you're creating an Azure function, it's a trigger-based service. So when you're deploying your program into it, think of it as, do I need to run this continuously? That one will kind of defeat the whole purpose of running something serviceless, because if you continue running, that's processor time that you're using. But if you deploy it and something happens to kick off the service, then that's event-driven. Or if it's like a time type of scenario where maybe every Friday some major business thing happens, maybe billing or whatnot, those are scenarios where you have like event-driven type of scenarios, and that will kick it off. So, or another scenario is, when you have like message queues too, you can have, or Kafka, where you have tons and tons of events coming in. Yeah, you need like some kind of way of dealing with those events at a timely fashion. So micro-billing, that's cost efficient. Toolless application platform components. So this just reiterates, when you're dealing with functions, developers can use their tooling, you have bindings and triggers, and you can deal with open source. Another thing with functions is you can integrate it with your storage systems. So whether you have databases, whether you have blogs for blob services for maybe your media files, you can totally use that. If you need something that needs to be kicked off like via email or whatnot, you can use that. Then we also have gateways to different components out there. So think of it of, let's say, dynamic CRM or Twilio, because Twilio is another event-based type of thing where if something happens, you can trigger maybe a phone call or an alerting type of system. So this one, I'll leave it to you guys to look at all the different connectors that you can connect to and not reinvent the wheel. The intelligence, you can also connect your functions to any, let's say you write like a machine learning code. You can totally tie it into your functional services. So depending on what the logic is, it can totally tie into machine learning. We also have cognitive services, which are another way to integrate with your services. Bot services, how many of you are familiar with bot services? Okay. Can you share with the audience your experience around bot services? Do you think it's useful? It's not useful? What's that?
They're arbitrary, but they will be useful, I think.
Yeah. So bot services is another good evolving way, technology around the industry right now, especially around customer services. A lot of companies don't have enough workforce where you can hire people to answer the same old questions. You can create a bot to interact with people, or sometimes when you call like a customer service number, you're talking to a bot there. So those are areas where you can have a bot. Cortana service is also another way of is within the framework of using bot services, or Alexa. So those are like areas where you can use Azure Functions to integrate with that. Okay. So I wanted to give you a 360 layout of serverless ecosystem, especially when you're dealing with functional programming. You have triggers with Azure Functions, and you could call your functions because the trigger, something happens, you have data, it's going to feed it into a function, and that function will do something. So you can use triggers. Another thing is the openness to the open source community. So this is a few of languages out there that you can also use in conjunction with that. As far as tooling, when it comes to F#, you can deal with, it's built around to support VB, CLI command scripts. It can be supported on Mac or Linux. Then you also have the other connectivity to third-party APIs that you can use to leverage what your services are doing. Looks like we have a lot on functions. Okay, so for functions, in a nutshell, I can just quickly run through. You have the same consistent programming language, which is very similar to F#, because F#, when you run your function, it has one purpose. It does one thing. So you pass in the data anytime, you're always going to get the same type of results. So it goes hand in hand with functional programming. You can publish your code directly from Visual Basic if that's your IDE tool. You can take advantage of Azure Functions on premises, or you can also run it in the cloud. There's also usability in the portal. You can use it when you're dealing with web workers. Like I mentioned, you can have triggers. So timers, SQL Server Broker, triggers, you can totally use that. So all of this is also tying it back to functional programming with F#. You need to integrate with all of this. So if you write a code, it's not just a mathematical thing that adds something up. You probably need some back-end coding to grab data and do some kind of logic for. Yeah, so right now we're working with more customers to validate some of these applications. How much more time do we have?
7 minutes.
5 minutes?
7 minutes.
Oh, okay. So one thing I wanted to show you guys was how you can use functional programming like F# and integrate it with Azure Functions to kind of create like a Homeland Security type of interface. All right, so this video is to depict activities at an airport. So if you're to implement like Homeland Security at an airport, what is a common thing that you see at an airport? There are tons of people going around, right? And when there are tons of people going around, nowadays you have people that are wanted by whether you're at a subway and whatnot, but how can you process all this information? Okay, I'll walk you guys through it. So basically what the code does is we have an API called the Video API, right? And with the Video API, it's able to detect facial images, right? And with facial images, even though that video clip that we saw had a whole bunch of people, if you notice, it's from the movie, what's it called? The Terminal. So it has Tom Cruise in it. Since Tom Cruise is an important celebrity in it, it already knows who Tom Cruise is. But what if there's another person in there that does not, that the video does not recognize? You can write a F# function that first is able to go through those videos and tag images. So you see a whole bunch of images, it's unknown. The next thing is you can go through and say, this person is John, this person is Mike. Then in your F# code, you'll be able to, let's say you're streaming live. Let me step you through the code. Okay. So we're going to create a Lambda function. So this environment is Azure. If you need to create a function, this is how you go about creating a function. You select what the function is, give it the name, your subscription, user group. Then this is key. You need to select whether it's a consumption plan. So consumption plan just basically means you're only going to be charged when you use a service. The app service.
We have run out of time.
Oh, okay. So I'm going to put the code in GitHub, and I'll send it to you guys. But basically, what the code is, you'll be able to take any video that you have, and with the the F#, you'll be able to identify anybody in real time. So whether you have like a static video or you have like a live streaming video, you should be able to detect who that person is or add indexes into the video, or even do searches in the video. And there are other cool APIs that you can do in it. But one thing I wanted to show you also in the code is how simple, how many few lines of code that is. Okay?